All right, what are we doing tonight? Okay. I've got a bunch of SAT practice problems. Does that work? I've got the ones that come from the board that does the test. So that's got to be the best ones to use. Are you scheduled to take the SAT? Tomorrow, okay. Let's go ahead and do as many of these as we can then. Tomorrow on a Tuesday, is this the SAT or a PS? It's SAT? Okay. Now, I actually give seminars on the SAT and the ACT, and believe it or not, this is one area where I can actually help you beyond the math if you want it. Not tonight so much because I'm not set up yet. I would need to go to meeting on my laptop where I have a PowerPoint presentation, but I do a 5-hour seminar on the entire test. And only half of it's math, so the other half is the English and the reading. So if you ever want any of those tips, I'd be happy to do a session and just tell you everything I know about the English and the reading. Were you a senior or are you a junior, Brandon? So you're going to have a chance to take the thing again next year. And that's the way to do it, is you want to take it at least twice. Have you taken it before, or is this your first time? Okay. Believe it or not, they're actually quite similar. Both of them start you off, both of them give you these formulas at the beginning of every section of math. Okay? You don't have to memorize these, just make sure you know what all those letters mean. So familiarize yourself with this page. In other words, know what the B and the H mean. Base times height. So forth and so on. Okay, the way I usually do SAT is just to go through the problems. It's not the way I do the seminars, but it's the way I do one-on-one tutoring with people. Is to just go through problems, starting with the easy ones. Now let me say a few things about the math on the SAT. It's the only part of the SAT that definitely goes from easy to medium to hard, depending on where you're at on the thing. Meaning, the very first question you get in math, like number 1 here, is going to be an easy one. You can know that for certain. And the very last question on this section is going to be a hard one. And that sometimes helps because time is a factor and you're going to end up guessing on some of these. And the ones you want to guess on are the hard ones, not the easy ones. You want to spend your time the most effective it can be spent, which is by doing the easy and the medium problems. Now, if you do all the ones you know how to do and you do all the ones you think you know how to do, the only thing left is the hard ones, and then spend the rest of your time trying to do those. But what's particularly important is that you spend most of your time doing the easy and medium ones. If you have to guess, it's not so bad to guess on the hard ones, and they're all worth exactly 1 point. The hard ones are not worth more than the easy ones. So let's start on the easy ones. Number 1. And I won't waste much time on these if you can get it right away. Give me the number, because I don't hear well enough to know whether you're saying B, C, or D when you say that. Do it again. Okay. You don't want to make simple mistakes like that on these easy questions. Seriously. The worst thing that can happen to you on the math is to know how to do the problem and make a mistake. It's one thing if you do not know how to do the problem. There's going to be lots of problems you're not going to know how to do. Guess gives you a 25% chance of getting the right answer. So that's another thing. Always guess. Never leave a question unanswered, ever. That's the first rule of SAT taking, regardless whether it's math or reading or English. Make sure you have all answers filled out before time runs out. Okay, number 2. Let me glide down a little bit here so we bring it up a little bit. Now, if you don't know what I is, no big deal. This is the easy part of the test. This can't be that hard of a question. It would be intimidating if you're not familiar with I. But it's not doable. If I told you to add those two things, what would the most likely answer be that you could think of? You got it. And that's the correct thing to do, is you combine the real parts and you combine the imaginary parts. Simple. Real simple. Okay, let's go back up to number 3. I'm going to start getting a little bit harder, but not that hard. Go ahead and read it. Yes. Now, this is an easy one that's not that hard to formulate exactly like you did it. Okay? But it could be harder if I put one more variable in the problem and it has to be divided. Then it starts getting confusing figuring it out in your mind how to do it. So I want to show you a technique that is a terrific technique called pick numbers. And where you use this technique, this is a type problem where it absolutely jumps out at you that I'm going to pick numbers. Okay? Why? Because I see M and P in the question, and every answer has M or P in it. That means M or P can be absolutely anything you want it to be. So, even though you didn't need to use this technique, I want to show it to you because it's really a clever technique for harder problems. I'm going to let M equal a real small number, and I'm going to let P equal a real small number. Now, how many texts did Armand send out? No, he sends out 2 texts each hour. So if M is 2, he's sending out 2 text messages each hour for 5 hours. How many did he send out? And if P is 3, how many did Tyrone send out? See, your mind automatically knows how to do that. Now, all we have to do is find which answer is equal to 22, right? Because they're asking you how many text messages were sent. Well, using the 2 numbers we picked, we can figure out quite easily that it's got to be 22. So, we need to figure out which answer is 22. Well, M is 2, P is 3, 9 times 2 times 3 is not 22. 20 times 2 times 3 is not 22. 5 times 2 is 10. Plus 4 times 3 is 12. 10 plus 12 is 22. There's our answer. And we didn't have to know how to do it, really. It's more valuable when you get to a really hard problem. It's a terrific technique for really hard problems. This problem is probably easy enough that the quickest way to do it is the way you did it. It's not that hard to come up with that as an answer. But sometimes they'll be harder, and it will be a little harder to come up with the answers. Okay? Now, be careful about coming to the conclusion that because it is a really long problem, it's really hard. It's not always true at all. Notice this thing has 8 sentences in it. But if you read it, it's not that hard. Go ahead and read it. Try to get a feel for what that formula means. What's the 108 mean? What you need to understand is these two things right here. You need to know what P is the number of phones left, and D is the number of days she has worked. So before she's worked any days at all, what's P? In other words, when D is 0, what is P? When D is 0, before she's even started her work that week, she walks into the office, what is P? Okay, so which answer suggests that? That's what she starts with each week is 108 phones. It's B, correct. But that's kind of the way you need to do the problem. Is you don't need to substitute 0 for D necessarily, but you can tell that as D goes from 0 to 1 to 2 to 3 to 4 to 5, the number of phones she has to fix get less and less and less. You know, at the end of 4 days, she's basically, 5 days, she's fixed them all. All right. Now, this is incidentally the no calculator part. You have experience with that. The SAT has a calculator portion. They have a no calculator portion. And they also have some questions that aren't multiple choice. They're grid ends. And we'll come across a few of those. Okay, number 5. Now we probably are no longer in the easy question section. Not going to be hard yet, but it's going to be about medium. So how do you handle polynomials like this? In this case, they're being subtracted. What's the first thing you do? Well, actually not. The first thing you always really want to do is get rid of the parentheses. Then put all the like terms together. And that's a very important first step, particularly when you have subtraction going on. If that, what I've just drawn an arrow to, if that's a plus sign, then I can just pull all the parentheses without changing anything, right? But because it's a minus sign, I cannot do that. Rewrite this thing without the parentheses, starting from the left. And you can always remove those first set of parentheses without changing anything. Those were not necessary to begin with. Second set of parentheses is very necessary. So what's the rest of the terms if I remove the second set of parentheses? Good. That's the key, is you have to distribute that negative sign to every term that's in the parentheses. Now, gather like terms. How many of these exactly do we have? Yeah, I see this one and this one. So how many do we have in total? What's x squared y plus x squared y? What's one apple plus another apple? Now, when you have really long polynomials like this, it can be useful to do this. Now, what do we have? How many y squareds do we have? What are they total? Okay, gets rid of that one, gets rid of that one. How many of these things do we have? And that gets rid of everything. That should be our answer. There, C. Sometimes multiple choice helps, sometimes it doesn't. In this problem, having multiple choice didn't help a bit. We had to go ahead and do it algebraically. But other times, multiple choice can turn a really hard problem into a real easy problem by giving you some of these techniques that I'm going to show you. Now, let's go in order. Let's try to do 6. Notice what format this is in. Y equal mx plus b, right? What's m? Okay, what's slope mean? Yeah, it also means the rate of change. That's the rise over run. That's why they spend so much time in school teaching you about slope, is because it's not just a line on a piece of paper, it's the rate of change. Calculus is all about slope, only it's instantaneous slope. Well, what's the slope in our formula here? That's the rate of change on a yearly basis. That's the answer. It's that easy. Now, there's some ways you could figure it out. Let me help you. In other words, if you didn't recognize that, tell me what the boy's height is at age 2. It's 3 times 2. Let's write it this way. Okay, so that's 34. Now, that's at age 2. Now let's figure out what his height is at age 3, and we'll subtract the 2, and that'll be the answer, right? So what is it? It's 3 times 3 plus 28.6. So this one came out to be 34.6. This one comes out to be 37.6. What's his rate of change for 1 year? Exactly. This would be the way you probably would do it on the test, as opposed to trying to figure out that this is the same as y equal mx plus b. Best way to do it is just to figure out his height in any given 2 consecutive years, and there will be whatever the difference is, that's his estimated height increase each year. All right, the next one's one of my favorite ones. Looks hard, but isn't. So let me just pop it down a little bit. Okay. Notice how much SAT goes out of their way to fool you. By that I mean all of this information, hold on. All of this information is completely irrelevant. It is. And so why are they giving it to you? That's the question. They're giving it to you to try to trick you. Try to make you think you're looking at a hard problem. But here's what the problem really is. M equals x times y divided by z times p. Okay? That's x. That is y. That is z. With me? Solve this equation on the left for p. If m equals xy over z times p, what's p equal? You've got to be able to solve an equation for any of the variables. In other words, right now we have everything defined in terms of m. But you got to be able to turn that around. That's definitely a skill you need on this test. You got to be able to solve this equation right here for p. So, how do we do that? We got to get rid of everything that's surrounding the p, correct? Let's start with the z. How do we get rid of the z? Yeah, right now the z is a divider. You're always doing the opposite. So the first thing I can say is m times z equals x times y times p. That follows from the first formula. Now how do we get rid of the xy? You always do the opposite of what it's doing. What are the x and the y doing to p right now? Okay, so how do we get rid of them? Okay, so the answer is mz divided by xy equals p, right? Well, that's all they're doing in this problem. Notice that all of the answers, well, we're looking for an m in the numerator. Well, they all have m in the numerator. There's an m, there's an m, there's an m, there's an m. But this one has z in the numerator, right? There's my z. In other words, that's z right there. That's in the numerator. And what do I have in my denominator? X and y. There's x, there's y. So we found our answer. It's this one right here, and we didn't have to know what R was, we didn't have to know what capital N was, we didn't have to know what P was, we didn't have to know what R was. All these things they give you are totally irrelevant to the solution of this problem. Because all you have to do is know how to solve an equation and turn it around. In other words, if y equals mx plus b, what does b equal to? B, over here. I'm giving you an equation, and what I want you to do is rearrange it to solve for a different variable. What would b be equal to? What's the m and the x doing to the b? Okay, so what do we have to do to get rid of it? So it's y minus mx. That's how you solve for b. That's always the case in all equations. You just take whatever is surrounding what you want to solve for, and you get rid of it by doing the opposite, one step at a time. Okay? So, one of the clues that you would have that this is not a hard problem is the fact that it's only problem number 7. And they go at least a 15 on this part of the test. Okay? So the fact that it's problem number 7 and not problem number 15 means it must be much easier than it looks. Because you got to admit, when you look at this, this looks like the hardest math problem you've ever seen. But it isn't. In other words, a person could spend 20 minutes trying to figure out how to handle that. Do I take it to the nth power? What the heck do I do with that? So it's all a trick question. It really is a trick question. All right. But they are quite tricky, intentionally so. Let's see, we're looking for number 8 here. And I'll keep track of how far we get on these sessions. Oh no, if you're taking the test tomorrow, this is probably our only shot at the SAT, huh? All right, let's look at number 8. Again, a lot of algebra on the SAT. A lot of algebra. A little bit of geometry, but much more algebra than geometry. So far, we haven't had any geometry. Everything's been algebra. So, what am I going to do? How do I figure out what 4b over a is? Okay, a good teaching point, because when you have no idea, do what you can do. In other words, you have no idea how to proceed, right? What the first step is? Well, what can you do? They're giving you that. What can you do with that? Can you solve for a? What would a be equal to? No, you can't solve for a as a number, but you can solve for it in terms of 2b. Solve that thing for a. In other words, get rid of the b. No, here, let's go through this. I feel like you're not grasping it. And this is really important. Okay? Here's what we're trying to do. We're trying to solve for a. So down here at the bottom, we're going to have a equals something. Well, what is around the a? What is with it right now? Okay, what's the b doing? So how do we get rid of it? Okay, so we multiply both sides by b, we get that. Okay? That was the only thing we could do, was to solve for a. We couldn't do anything else. Now, let's look at where we're at. Now we have this, and they want to know what 4b divided by a is. Well, a is 2b, right? So now that's pretty easy. What's the answer? Yeah, the b's cancel. And you're left with 4 over 2. So, it's just another thing where do whatever you can do. Now, there are some tricky ways you could look at this problem. One of them being that if a over b equals 2 over 1, which is correct, then what is b over a equal to? Okay. And what is 4b over a equal to? In other words, once I know that 1b over a equals a half, then what's 4 of them going to equal? Yeah. In other words, this is 4 times bigger than that. So multiply both sides by 4. There's our 4b over a. There's our 4 over 2. And we've solved it that way also. So there's multiple ways to solve this problem. Okay. Now, number 9. How are we going to solve number 9? Here, I'm going to scroll down a little bit so I can create some writing rules. That's good. You're looking at a system of simultaneous equations, and there's definitely going to be some of these on there. 1 or 2 questions about simultaneous equations. This is actually a relatively easy one. Is it going to be easy or hard to solve it by substitution? Myself, I would solve it by elimination. The reason is I have all the x's and y's on the left side and I have all the numbers on the right side. Okay? So, let's solve it by elimination. It's not actually the way I would solve it, but I will show you how I actually would solve it. Now, notice that to solve it by elimination, I got to switch the 2 terms in the second equation, right? Because I need the x to start and the y to be second. Okay? Now, how do I solve this by elimination? What's the first step? No. You got to eliminate a variable, hence the name elimination. Okay, let's do that. Makes it the same equation, but now it is suitable to have a variable eliminated. In other words, that's our new equation. Instead of, this was number 1, this was number 2. Or if the other one was number 2, now this is number 2. Now, how do I eliminate a variable? Conceptually, what do I have to do to these 2 equations? Add them together. You're always allowed to add equations together or subtract them. Turns out here that adding them together is going to get rid of our x variable. Right? What do we get if we add those 2 equations? We're adding that to that. We're adding 2 negative numbers. What's minus 23 plus a minus 57? Minus 80. Okay, so what's y? Now, notice something. If you were taking math class, you would have to go ahead and then solve for x, right? In other words, they always want both variables. And in fact, all of our answers over here have both the x and the y coordinates. But how many of them have minus 8 as the y coordinate? And we're done. We do not have to solve for the x coordinate anymore. It's got to be 3. If there were 2 minus 8s in there, we'd have to keep going. But we've solved for y. That's all we needed. And if we'd have done it slightly different, we could have solved for x and we would have gotten 3, and there's only one 3 on there also. So this is a problem that you're only going to have to do solve for one variable. However, there's another way to do it. Let's say your mind went completely blank and you have no idea what to do. Let's talk about back solving. Because back solving and picking numbers are the 2 greatest techniques for answering harder problems. Back solving means I'm going to pick an answer and plug it in and see if it satisfies that equation. And I'm going to pick the simplest equation, which is the second one. So, that's y minus, that's x, right? Is that equal to minus 19? That's not the answer then. Let's go to the next one. That's y, minus x. You see where I'm getting the x and the y, right? In other words, I'm getting them from down here. Each of these answers is the x-coordinate and the y-coordinate of the solution. So I'm merely plugging them in for x and y. I'm plugging in minus 8 for y, and I'm plugging in 3 for x. Is that minus 19? That's our answer. Notice I only had to do 2 calculations. I didn't have to know anything about solving simultaneous equations. So all I had to do was check each of these 4 data points and see which one works. Now, if one of them works in both equations, then you have to check further, but they're not going to give you that. Once you find one set of points that works in one of these equations, you have found the answer. Okay? Go to 10. Now, this is a little bit about functions. What math level are you taking, Brandon, right now? Algebra 2? Just Algebra 2? You've gotten functions, right? So what's g of 4 mean? If this is g, what does g of 4 mean? What are we going to do? No, there's a real simple answer to that question. And you want to do it every single time, and it has to do with what's inside the parentheses, and it doesn't matter whether it's a number or a y or an r or an x plus y. Whatever's inside the parentheses, you plug in for x. When you're given a function that says g of x, and then they say, what is g of 4? I got to plug in 4 for x. So g of 4 is 8 times 4 squared. I didn't mean 8, I meant a, plus 24. You with me? That's 16a plus 24. And they're telling us that that's equal to 8. Okay. What's that allow me to solve for? What can I solve for from that equation right there? There's only one variable in there. Okay, what is it? You can do this one in your head. What is it? When I move the 24 to the other side, what do I get? Okay, negative 1. That means our g of x is truly, a is negative 1. I just solved for it, times x squared plus 24. Now that we know what a is, they want to know what g of minus 4 is. So what am I going to do? No, the answer to that question is I'm going to plug in minus 4 wherever I encounter x. That's how you answer that question. If I said, what is g of 3? You'd answered, I'm going to plug in 3 wherever I find x. So I'm going to plug in minus 4 wherever I find x. And I'm going to use parentheses because this thing's being squared. Now, do the math, figure out what that's equal to. Do the exponents first. In other words, you got to remember your PEMDAS. So square minus 4 first. What's minus 4 squared? Now simplify that. It's minus 1 times 16. It's plus 24. Here's your answer right there. Now, that's the hard way to do that problem. That took us probably, it would have taken you 2 or 3 minutes to do it that way. Okay? There's actually, and there usually is on almost all of these problems, a shortcut. They're telling you that g of 4 is 8. That means when I plug in a positive 4, I get 8. Okay? Well, notice that when I plug in a negative 4, nothing changes. I'm squaring it. So positive 4 squared is 16, negative 4 squared is 16. So since that's the case, g of 4 has to equal g of minus 4 right off the get-go without doing any work at all. I can tell because it's being squared. So I know right away the answer is 8 in 10 seconds instead of 3 minutes. Okay, now I don't know, that's just something you kind of have to notice. But the one thing you should definitely realize is that if you take a negative number and square it, it turns positive. And once you come to that realization, then you realize that g of negative 4 has got to be the same as g of positive 4. Or g of negative 2 would have to be the same as g of 2. Because that 2 is getting squared, whether it's positive or negative, it's going to come out to be the same number. All right, let's go up and look at 11 here on the right. Okay, now we know we're getting into the, here, let me go back a step here. Let's see. Okay, so the last problem on this section is 15. Okay, and another tip, whenever they start a new section, like the next section is the grid end problems, it starts over again, easy, medium, hard. So we're going to find that 15 is a hard problem, since that's the last one. So is 13, going to be hard. But then, when we get to the grid ends, 16 is going to be easy. We're starting all over again at the easy, medium, hard level. So the first couple of the grid ends are going to be easy, next couple might be medium, and the last couple would be hard. So that's the way it works, which actually should be helpful to you. Because it really does help if you know whether a problem is supposed to be hard or not. Okay, let's look at number 11. Let's go ahead and read it. So this is the price, excuse me, let me. So this is the price per pound of beef. This is the price per pound of chicken. And the X represents the number of weeks after July 1st. Okay? So on July 1st exactly, what's B equal to? What's the price of chicken equal to? Yeah, but notice as we go into July, chicken's going to go up faster than beef. Why? Because it stores longer. In other words, what's really going on is beef is dropping because time affects beef more than it does chicken. Chicken, 1-month-old chicken is better than 1-month-old beef. Okay, but here's the thing. What was the price per pound of beef when it was equal to the price per pound of chicken. So what are we going to do here? This is the price per pound of beef. This is the price per pound of chicken. They want to know when they are equal. What equation can I write? No, don't guess. Don't guess. Let me say it again. This is the price per beef. This is the price per chicken. When are they equal? What am I going to do if somebody's asking me when are they equal? I'm going to set the right side of their equations equal to one another. In other words, I'm going to say B equals C. That's what they're asking. When is B equal to C? Well, that's the same thing as saying when is 235 plus 0.25x equal to $1.75 plus 0.4x, right? That's what it means. That's the price of beef. That's the price of chicken. So solve that for x. Gather your like terms. Which side are you going to take your x's to, the right or the left? Yes, very good. It's because it leaves it with a positive coefficient, right? That's the reason you take it over to the right. You're going to be left with that. Which side are you going to put your numbers on? What goes on the left? What's 235 minus $1.75? 0.6. And this is a no calculator section, so I should have made you do that. And when we're doing it, I want you to set your calculator aside. In other words, try to put yourself in the mode you're going to be in tomorrow when you take the test. You're not going to be able to use a calculator on this problem. You've got to be able to do this by hand. Now solve that for x. Well, first of all, how do I solve it for x? Tell me. Got to get rid of the 0.15, right? How do I get rid of the 0.15? Okay. So x is going to be 0.6 divided by 0.15. Now, if I add a 0 to that, it becomes pretty easy. How many times does 15 go into 60? That's the answer. However, it's not really the answer, because that wasn't really the question. We got to go back and we got to look at this question a little bit deeper. And what they say is they didn't say how many weeks after July 1st are they equal. They said, what's the price per pound of beef when they're equal? So we got to substitute 4 into this equation because that's the price of beef. So beef would be equal to 2.35 plus 0.25 times x, which we know, in other words, 4 weeks after July 1st, the price of beef is going to be equal to the price of chicken. Well, they want, what is the price of beef going to be at the end of that 4 weeks? Well, if you do that in math, yeah, it's good. 335, and that's your answer. Okay. All right, let's see if we can get in another couple ones here. It'd be nice if we can do all the easy through hard, just to give you an idea of what really is an easy problem and what's a hard problem. Some of these harder problems aren't that hard. Okay. So here's kind of a, I don't know if you call this geometry or algebra. I suppose it's still algebra. Actually it's not. It's geometry of the XY plane. you're going to get a number of questions regarding geometry of the XY plane. A line, that means a straight line, passes through the origin, means it goes through there, and it has a slope of 1/7. Is that a flat slope or a steep slope? Yeah, it's rise over run. So for every 1 that I go up, I got to go over 7, right? So there's a line that is approximately equal to the line they have described. It's going through the origin and it has a slope of 1/7. Now, which points lie on that curve? Does 0, 7 lie on that curve? No, you can tell. There's zeros down there. Y is not 7 at that point. Okay? Does that lie on that curve? No, because that would be only over 1 and then up 7. Does that lie on that curve? What do we know the answer is? What's our next step? Go to problem 13. In other words, you do not want to make a mistake of wasting time checking an answer that you know has to be right. If I drew this thing correctly, absolutely those first 3 answers cannot be right. Not even close. Whereas 14.2, yeah, that works. If I go way out on 14 on the x, I'm at about 2 on the y, with a slope of 1/7 for sure. But I don't need to check it. Once I've eliminated 3 answers for sure, I know the 4th one is correct, and I'm circling it and going to the next. All right, let's have a look at problem 13. Now we're pretty sure we're in the hard section, just because it's 13, and there's only 3 problems left in this section. So, let's talk about how we're going to do 13. We'll start with something simple. How do I add, fractions? Because that's essentially what they're asking us to do here. They're asking us to add those 2 fractions. So how do I add just 2 fractions that are 2 numbers? The common denominator, the least common denominator. Well, what is it here on the right? The least common denominator is 12. Now, what's this numerator? What's that numerator? 3 on the left, and what on the right? So now what do? Now we add the numerators and we carry forth that least common denominator. So there's our answer. Okay? Follow that logic? Okay. So now let's make it a little bit harder. And let's add something that has a variable in it. In other words, our problem. Even this isn't the whole problem yet. This is just the denominator, but we have to add these 2 together. How do I do it? Yeah, when you're dealing with variables, how do you find the least common denominator usually? You multiply them together. No, you multiply them together. The least common denominator is going to be x plus 2 times x plus 3. And write it like that. Don't multiply them together yet, and I'll show you why. What's my numerator in the left part have to be? so that it's equal to that fraction. Yeah, easy, right? And you can tell it if you don't multiply the bottoms together. It's real easy to tell that that is the same as above. What goes in my right-hand numerator? Okay. Now combine those. What do you get? Just you're adding the numerators. All over. Now I'm going to go ahead and multiply them together just because all of the answers have them multiplied together. Okay, so that is the denominator only. When I divide 1 by that denominator, how do I do it? In other words, I'm going to create a fraction. There's 1 divided by that thing. How do you do that in math? How do you divide by a fraction? How do I divide 1 by 3/4? You flip and multiply. You can't just turn a division problem into a multiplication problem. I can't just take 1 divided by 3/4 is the same as 1 times 3/4. It isn't. Always have to flip the bottom and then multiply. So this becomes 4/3. So what does this thing become? That answer right there, B. Okay. And you can see that that was quite a bit of work because it's not that easy to find a common denominator for most people when you're dealing with variables. But that's what you do. You multiply the variables almost always. And that's your common denominator. And you have to figure out each numerator, and then you have to flip and multiply because 1 is being divided by all of these. Okay. We got time for one more here. 14. This is a pretty good one too. Let me give you a problem. Thinking for a moment. We'll make it easy. How would I solve that problem on the right? You have to find a common exponential base to both of these numbers. In other words, is there a way I can write 9 as 3 something? It's 3 squared, right? So I can turn this thing into 3 to the x equals, and instead of writing 9, I'm going to write 3 squared in parentheses and take it to the same exponent. Now apply your rules of exponents. What's the right side equal to? What do you do when you're doing double exponentiation to the exponents? What about the exponents? What do you do with these exponents here? Yes. So what's that new exponent? Now look what you have. You have 3 to one exponent equals 3 to a different exponent. What can I do to those exponents? Set them equal to one another. They have to be equal to one another. It's the only way that could be a true statement. Now it's just a simple equation. 3x equals 1, x equals 1/3. There's your answer. Okay? The key on all of these problems is to look at your numbers and see if you can find a common exponential base, not a common factor. 3 happens to be a common factor to both 3 and 9. But that's not what we're looking for. We're looking for a common exponential base. Now, let's look at our problem. We have 8 to the x divided by 2 to the y. That's what they're asking for. Well, do you see a common exponential base anywhere? Okay, what is it? Nope, it's not 4. By a common exponential base, it means, can I write 2 exponentially and can I write 8 exponentially? Well, how can you write 8 exponentially if the common base is 2? What does 8 equal to? 2 cubed. So I'm going to write my 8 like that. And the bottom already has 2. I don't need to do anything with that. Okay? Can you see that blue? It's a little bit hard to see. Apply your rules of exponents. What's the top become? What's the bottom become? Now apply your rules of exponents to that. What does it simplify to? What do you do when you're dividing? Same base. What do you do to the exponents? Definitely want to know your rules of exponents. That's the very first thing I cover in my presentation, because there's a lot of questions on the test about exponents. So you want to know when you're adding the exponents, when you're subtracting the exponents, and when you're multiplying the exponents. That's the only 3 cases. When I'm dividing, what am I going to do to the exponents? Yes, you're never doing the same as what the base is doing. If you ever find yourself doing the same, you're doing it wrong. Okay? So, that's what this expression is equal to. Exactly. Right? Well, guess what they give you over here? They tell you what 3x minus y is equal to. So what's our answer? Yeah. Okay? And this, just before I let you go, let me give you a slightly harder one, just so you get the concept. What's the common exponential base between 9 and 27? And the answer means you have to be able to take that base and represent 9. And you have to take exactly the same number and be able to represent 27. So what is that common exponential base? It's tempting to say 9. It's tempting to say 9, right? But it isn't. 9 is a common factor. There's a difference between exponential base and factor. What we're looking for is how to write 9 a different way, and can I use the same number to write 27? Well, what's another number that you think might be the exponential base? Perfect. Now write 9 as 3 something. Nine is what? 3 to what power? 3 squared. That's the number 9. I still have the x up there. Now you have to write 27 as 3 to the something power. Three to the third. That's 27. Now notice I've got the same exponential base on both sides of my equation. I apply my rules of exponents by multiplying them. Gives me this. Now I have 3 to some exponent equals 3 to a different exponent. I can set that equal to that and solve for x. So the common theme here is this common exponential base. This is relatively easy because it's easier to see that you can represent 8 as 2 cubed. Over here, it's not so easy to recognize that 3 is your common exponential base. In other words, you have to be able to write each of these numbers in terms of 3 to some power. Because that's the only way you can apply these rules of exponents, is if you have the same base. I can't do anything with 9 to the x and 27 to the 2x. Those are different numbers. Except for the fact that they do have a common exponential base, 3. So I can do something with them as long as you have a common exponential base. All right, Brandon, I'll let you go. Good luck on your test. Get a good night's sleep. That's the most important thing. And that's the second most important thing, too. Have a decent breakfast.